Yeah, guys, we should have recorded it long time, you know. So basically, as we discussed when we're doing the vector algebra, the x-axis is on the top, right? The x1 is on the top. So this is x and this is y. So we know that x runs from either left to right or right to left, right? So like we're positive and we're going to our right, that would be positive 4. In this case now we're going up. Just like with the Cartesian plane as I show you guys here. If you're going up, it's going to be positive. And then you just simply say how many places you move up. And in this case it was 3. So that's the vector 4, 3. So you see it doesn't necessarily have to have numbers on it for you to have the vector. Now we look at our next one just for more clarity. Because one example, now I'm going to really get it. So I'm going to see if we can get it further. I try to draw that one as straight as possible. Alright, I could call this one CD. So we want to name this vector. As I said, guys, you just observe the start point. You can know the start point because you see the end point, that's where the arrow is pointing at. So we know, so we end at D because the arrow is pointing at D. Just like in this case, where the arrow was pointing at B, that's our end point. So this is our end. You guys have this in the notes, so this is your start. So that's how you know. Whichever the arrow is pointing to, that's your end point. So that means this vector is going from C to D. Agree? It's going from C to D because D is your end point. Whichever way the arrow is pointing, that's your end point. So that means this is our starting point. Remember, we cannot go down first. We always have to move either left or right because the x-axis comes first. So that means because the endpoint is located to the left, it means that we simply have to go that way here. Let me change the color so we can just kind of highlight what I want. So basically now we move 1, 2. So we move 2 places. But guess what? It's to our left. So we know that on the Cartesian plane, if we move to our left, that's negative. And then now we're gonna go down. So let me just change the color again, just to highlight something kind of important. And then you say 1, 2, 3, 4, 5. So we're going down, guys. And this, whenever you're going down, it's negative. So this the vector.
So that would be -5.
Correct. Because we're going down on the y-axis. Alright?
Sir, why did you go to the left?
No, man. If you're going to the left, that the x is negative. But when you're going down, y is negative. Alright. For those who join late, let me just show you something. Guys, as I say, it can be so easy or it can be so frustrating. So in this case, that one is -3, -5.
Sir, John Hall said if you could let him in the meeting. The John Hall says if you could let him in the meeting.
Yeah. You see, Jaden.
Is it -3 or -2?
2. Sorry. My apologies. Because it's 2 places to move, right? 1. Oh, see 2 there right now, so I'm not sure. Not sure why I write 3. Yeah, guys. So it's the number of places we move to our left and to our right. That's what determines the vector. I could look on another scenario. So basically, these are 2 positive because we're moving to our right and we're going up, right? This one, we're going to our left and then we're going down. I could do another one. And I basically want to capture all the possible scenarios. So I could say one goes so. Alright, I could call this one PQ. Let me ask guys, where is the endpoint on this? Is it point P or point Q?
Q, sir. Q.
Q.
And Q, sir.
Yeah, because the arrow is pointing
Q, sir.
towards, yeah, it's pointing towards Q. So that means we start at P. So you can just use your sense and say, all right, you can't go up or down first. You have to either move left or right first. Always the X you have to do first. Remember, you know, guys, nobody never teach me vector. You know. I observe, I have to just observe this. All right. This one I have to become self-taught myself. Because when I was going to school, the teacher them never make we CXC never make you choose. CXC make you choose. So that means so we are going to the left first. So we have 1, 2, 3, 4. So that means it's -4 because once you go into your left, just like on the Cartesian plane, x is negative. Alright, and then now we're going up. Because we have to match it, you know, we have to go straight to it. 1, 2, 3. So this is, should this be negative or positive? Or what you guys think?
Positive.
Positive, sir. Positive.
Yeah, because y you're going up. If it was a case where we're going down, then we would have -3. But because we're going up, y has to be positive. So what we can do, we can just write from P to Q. That's what it means. P are your starting point. It's, and you always do your x first. Just like in the alphabet. So it's -4, 3.
Sir,
Yeah man, go ahead.
why you couldn't go up with from the P, why you couldn't go up?
Alright. Because you always have to move your x first. That's the rule. Alright? Always. In all the cases, just like with this, we start here, we could have easily well go up, so right? No, we can't do that. Always have to go. Because it's an alternate route you have to take, you know. With vector, it don't go directly. So you just have to look where the starting point is relative to the end point. Alright, so make a look at this scenario we have. We have x positive, x, y positive, this negative, that negative. So x negative, y positive. That means I need to show you one now where x is positive and y is negative. That's the 4 scenarios that you can have. Alright. So now see what I'm going to panic with. We have more space, you know, guys. We have more space.
For this, you would have used a T-graph.
No man, they don't necessarily have to give you a graph, you know. This is just to show you how vectors work. If you're gonna need graph, if normally after the position vector. But you see, once you understand how vector work, then it becomes so much easier for you. Alright, let me use x and y this time. Alright, so that's a x, that's a y, right? And as I say, it depends on the starting point. This is the start, this is the end. Whichever the arrow is pointing on, that's our end point. So to find the vector, what we need to do is we're going to start going to our right, because we cannot go so first. Always either to our left or right. So we have 1, 2, 3, 4, 5, 6. Now, is this positive or negative? We're going to our right.
Positive.
Positive. Thanks, Anthony. So it's
Positive.
positive 6.
Positive, sir.
Yeah. And then now, to match it back, we're going down. So it's
Which is
1
negative.
negative.
That will be negative, sir.
Yeah, that is it. So to write the vector now, it would be xy. This over it means the vector from x to y, that is equal to 6, -2. Because we always have to write the x first, guys. I think once you remember that, then you cannot get it wrong. So the
So you can
vector.
find
Yeah, man, go ahead.
you can find the vector of something on a plain paper.
Yeah, we can use algebra and find it too, you know. But even if you have a plain paper, you can draw it, but they will give you the coordinates if they're gonna ask if you find the vector. But they make it easy for you, they will give you it on a grid. But if you have a plain paper, you can do it. Or if it's a position vector, they will give you the coordinates and so. So the only difference with this, guys, notice there's no number on the grid, but yet we can create the numbers. On the position vector, we actually use the Cartesian plane in a sense because you start at the point 0, 0. Somebody up play music, man. Alright. That would be it, guys. So I could look at all the 4 scenarios because this is basically it can be different from these. It's either one of them here. It's either 2 positive, 2 negative, or x negative, y positive, or y positive, x negative. This is just the 4 scenarios that you can have.
Sir, when I'm asking for write a vector, sir, you'll get like, so you would like me see a T graph on the right on the screen. That's what I'm gonna ask if that's
No,
where you put in
man.
the value.
No. You see, this was just to explain when you're going to our left and to our right. Why, when we're going to our left, it's negative on the x. Why, when you're going to our right, it's positive because it's based on the Cartesian plane.
All right, sir, thank you.
Yeah. I think because I came in a little bit late, but this is what we're reasoning, right? So that's all you know. All right. So any
Sir,
questions?
can I
You
pull
guys
up
have
the screen a little?
You guys have your graph leaf. Wait, let me just do that. You guys have graph leaf because I requested that you guys have graph leaf from Sunday. If you do, you can take it out, please, and make it, just to see if where we
Yes,
are.
sir.
I will give you, yeah. And guys, you can take your time and draw it. Do it neat as possible. We just want to get this thing on the way. Oh, design. I don't see nobody now waiting. Very military. I don't see that. Oh. Oh yeah. Oh, you're on. Chanel, I just got your text, you know, I just seen it. Chanel, you're 20 minutes late, man. Oh God. Oh, for the new person, join with your name, yeah? I just become expecting me the person without the name. Alright, guys. So please ensure that you have these examples, guys. And if you have any questions before we attempt for you guys to try some on your own. So that was Wednesday. Hopefully everybody catch the concept. As I said, guys, it can be very easy or it can be very frustrating. It's one of those things where, like, I think I get it, but you don't quite get it. All right, everybody have those?
Yes, sir.
All right, guys.
No,
Thanks
sir.
very much. Oh, all right. Guys, do them neat here. I'm pause the video. Do them neat as possible. Because I really want you guys to project